Hey everyone, we are going to be looking at multiplicity of roots in this video. This is from the notes from 3.5. This is part 3, or the third video, on multiplicity of roots, or zeros. Okay, so in your notes, make sure you're writing this down. Sometimes a polynomial equation has a factor that appears more than once after it's factored, and this is going to create something called a multiple root. Check out example 1a. So when we factored 1a, we ended up with this. It has roots of x equals 0 and x equals -3. So when we set each factor to 0, we found those zeros, and that was from the first video in the series. The root 0 shows up 3 times, because if you think about what x to the third means, if I expand this, it was 3 times x times x times x, and then we have the x plus 3 and the x plus 3. So this x shows up 3 times and has a 0 of 0. And so it is, and that's because it was cubed. So it shows up multiple times, and we'll talk about what that means for multiplicity in a second. The root -3 shows up twice because the factor x plus 3 showed up twice. So if you look at this, we got x plus 3, or x plus 3 squared is another way to write that. That factor shows up 2 times. So it's going to have a multiplicity of 2, which is what we're going to talk about next. Okay, the multiplicity of root r. So it's the number of times that x minus r shows up after you've factored a polynomial p of x. If the multiplicity is even, make sure you're filling these in. If the multiplicity is even, the graph of p of x is going to touch or be tangent to the x-axis, but it will not cross through. So just touch and come back up, or from the bottom and go back down. Just touches it, doesn't cross through the x-axis. And then when the multiplicity of a root is odd, the graph is going to cross the x-axis. And if the multiplicity is odd and greater than 1, it's going to also cross through, but also have a little bend when it crosses the x-axis. Okay, so we're going to do example 2a. And if we look at this, it says, factor this given that x minus 3 is a factor. If x minus 3 is a factor, then when we factor x cubed minus 9x squared plus 27x minus 27, we should get a remainder of 0. I'm going to use synthetic division, and what goes in the little box is what makes this factor 0, which is +3. And then I'm going to list my coefficients and watch for any missing terms. I have a cubic and then a squared term, a linear term, and a constant. There are no missing terms. Leave a space. Remember how to do this. Drop the 1 straight down, multiply 3 times 1, and put the result over here, and then you add. -9 plus 3 is -6. Multiply, we get -18. Add, we get +9. 3 times 9 is 27, and when you add, you get 0. This is my remainder. So x minus 3 is a factor of the original function, and we can start factoring this. It factors into x minus 3 times the quotient. So this was our divisor, and if you take the divisor times the quotient, which we're going to get from these numbers right here, those are the coefficients of my quotient, we'll get, this is going to be the constant term, this is my x term, this is x squared, so I get 1x squared minus 6x plus 9. And that is a trinomial that can further be factored. So let's do that. We have x minus 3 times, you try to factor that. We're trying to figure out where this is equal to 0, so I have this over here. It's actually x minus 3 times x minus 3. So my 0, I have 1 0, x x minus 3 equals 0 when x is 3, so 3 is my 0. How many times does that factor show up? Well, 1, 2, 3 times. So I could rewrite this as x minus 3 cubed equals 0. So I have a 0, and it has a multiplicity of 3. And because it has a multiplicity of 3, 3 is odd. So you look at how many times the factor shows up. If it's an odd number of times, we know that the graph is going to cross at that point. But not only that, we also know that because 3 is an odd number that's greater than 1, it's also going to have a little bend when it crosses the x-axis. So you can see that I put the equation into y1 into the graphing calculator, and if I graph this, you can see, trace to 3, we end up with a graph that crosses at 3, because that was my 0 or my x-intercept, and it crosses through because it showed up an odd number of times, but it also has that little bend in it because it's an odd number of times that's greater than 1. So if you get like a multiplicity of 3, 5, 7, it's going to end up, when it crosses through, it's going to end up with that little bend in there. Okay, so let's do the next problem. All right, so let's do this next example here. We have x minus 2 times x plus 3 squared times x minus 4 equals 0. And notice that this is already factored, so we don't need to actually do the factoring here. But what we are going to do is we're going to find our zeros, and we're going to find the multiplicity, and then we're going to look at what does that mean for the graph. And I'm going to make a little table. It can make it a little bit easier to just kind of keep track of everything when we have more than one zero. And then I'm going to interpret what the meaning is for the function. Oops, for the graph of the function. Is it crossing or is it tangent? And if it's crossing, does it bend or just go straight through? That's what I mean by that. Okay, so x minus 2 is a factor. It will equal 0 when x is equal to 2. So I have a 0 of 2. That multiplicity is 1 because it is a factor. If I expand it, it still just only shows up one time in my factored form. Multiplicity is 1. And then what does that mean for the graph? So 1 is odd, and because it's odd but not greater than 1, like 3 or 5, it crosses through the x-axis. It crosses straight through. And then the next 0, we have 2 more zeros. You guys try to fill out this table. Pause the video, fill out the table, and come back. So you should get zeros of 2, -3, and 4. We already went through the 0 of 2, but the 0, if the 0 is -3, its multiplicity is 2, because if I expand that, x plus 3 squared means x plus 3 times x plus 3. It's a factor twice. So that's an even number. So if it's even, remember, it's going to just touch the x-axis, or another way to say that is be tangent to the x-axis. And then this next one, when x is 4, it showed up an odd number of times, but greater than 1, so it's going to cross and bend at 4. So let's look at the graph of this. So you can see that I put that into y1. And I had to kind of fish around for a good window. I needed to go pretty high in the y direction. Well, here I'll show you what my window is. I went from -5 to 8 and -200 to 1500. And so this is what the graph looks like in that window. And notice that if we trace to, my zeros were +2. And at that point it crosses through because that was an odd number of factors of x minus 2. And it was a factor one time, so it doesn't bend there, but it does cross through. The next one was at -3, which was an even multiplicity. So notice, so what it means to be tangent or just touch the x-axis is it comes down, it comes back up, it doesn't cross through, it just touches there. And then if we trace to the next one, which is 4, you can see that it crosses through there, but it also has this little blip. It has a little bend. Kind of just goes a little bit. And that's because it was an odd multiplicity. That's why it crosses through. But then it also has a bend because it's odd and greater than 1. Because it was 3. All right. That is it for multiplicity. The next video we're going to talk about the rational roots theorem.